Welcome to Three Devs and a Maybe, the podcast series for beginner web developers and general web enthusiasts. Now, introducing your show hosts, Michael Budd, Fraser Hart, Lewis Keynes, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're lucky to be joined yet again by a good friend of the show, Scott Wlaschin. How you doing, Scott?
Hi, thanks for having me on.
Well, thank you again for coming on, man. I think it's been like 3 times this year so far. So, yeah, let's keep this streak going.
It's good.
Awesome. How you doing, though?
Things are fine. I'm quite busy, actually, doing various contracting work. But yeah, the usual life of an independent software contractor.
Do you find it comes in like ebbs and flows, or do you kind of have a consistent work-life balance?
Yeah, it does come in ebbs and flows. And so, yes, you tend to be very busy and then not so busy. And in the downtimes, I really should be doing stuff like doing more writing and stuff like that, which I should do, and I haven't. But there you go.
Oh, well, you need to have some breaks in between,
Yeah.
One thing actually that you came up on your Twitter feed, I think it was last week, and you retweeted it, and then I subsequently retweeted it as well, was this. There was a series by, I think it was Chris Krychow, and it's entitled Exploring 4 Languages. And it was really interesting because he essentially took your DDD book examples and has started to write them in different languages and kind of, explore how different languages tackle these kind of aspects. And I just wondered, it must be brilliant for you, to see people taking these examples and kind of using them and expanding on them.
Yeah, it's really nice. It's really kind of a nice feeling when someone's actually using your book and they're finding it useful and stuff. Yeah, he's doing it in Rust, Elm, F#, and Reason, and trying to see. I guess he's mainly a Rust person. I think he's done a lot of Rust blogging. But he was curious about using some other languages, and he thought this would be a good way of trying out other languages in the context of doing domain-driven design or type-driven design. And it's actually very interesting. I mean, I think Rust is very different from the other 3 because of the whole how it does memory management, and the whole ownership thing is you can't just create stuff on the fly and do garbage collection. So the other 3 languages are garbage collected. I think that makes quite a big difference. And then I think Reason is basically OCaml behind the scenes, which is, of course, very close to F#. So the main difference with Reason is really the syntax. It's got the C-style syntax with curly braces, and it's got a tool chain. So it's got the OCaml tool chain, and then it's got some JavaScript tool chain on top of that. And I think that some of the problems he's having are to do with, you have to know, like most things, there's leaky abstractions. You can say, well, we're just using this language. But when it's built on top of another language, which is built on top of another language, you have to understand, when something goes wrong, you have to understand everything in the whole tool chain. And so you have to really understand how OCaml works, and you have to understand how JavaScript works and how the JavaScript ecosystem works, and, Webpack and Node and Babel and all the, I don't know. I mean, I'm not sure exactly what the toolchain is, but it's never that simple, unfortunately.
I think that's so true, isn't it? And I think it's interesting because, you mentioned that, kind of the tool chain, and it's even the case of things like Clojure and Scala. They're built on the JVM, but you kind of, although they're different languages, you still have to understand and respect what the JVM does and how it kind of maps it, which is obviously a very Java-y world. Similar with the CLR.
It is. It's the same thing with people coming to F# for the first time. And it's like, all I want to do is write some code, and I have to understand all this .NET stuff. And I have a lot of sympathy for that. I mean, languages that have complete control over their toolchain, like OCaml or something, it's a lot easier. I think in some ways it's easier to get started. I mean, the downside is the ecosystem is a lot smaller. And I mean, once you do understand the .NET toolchain, you can use any .NET language. It's the same thing once you understand how the JVM works, whether you use Scala or Kotlin or Clojure or whatever. I mean, the behind the scenes stuff is going to be working the same way. So it's a plus and a minus, I think.
Yeah, it's kind of that initial hit for the fact of, the portability, expandability in the future. I suppose not really portability. That's the Java philosophy it was meant to be. But, that kind of way of, you're being able to explore and take new languages and different libraries from different languages. And I mean, it's interesting, actually, in your F# work, do you take advantage of that? Do you use a lot of C# languages and C# libraries, and things like that?
Yeah, absolutely. I mean, if you, for example, I'm using in F#, I use Dapper, which is a database library written in C#. There's obviously a lot of F# libraries you can use directly, or you often have F# wrappers on top of. So, for example, for testing, you might use NUnit, but you might have an F# wrapper on top of NUnit, but you're still using NUnit behind the scenes or whatever the testing framework is. And if you're doing the .NET libraries are already massive. I mean, they're built-in massive ones. So if you're doing HTTP stuff, you have to understand the .NET HTTP code or the file, files and IO stuff, writing to a file. You're basically using the .NET file library for doing that. So you have to understand that. And they're written, typically when you go to the documentation's written in C# examples. And it's very object-oriented. It's not necessarily designed to be functional friendly. So a lot of time people do write F# wrappers on top of things to make them a bit more functional friendly.
Now that makes sense. Like a nice thin wrapper that then kind of provides it in the way that you would want to use it in a functional world.
Exactly. But the nice thing is you don't have to, I mean, with .NET and the same thing with Java, almost certainly you want a library that does something, there's a library that does it. And you don't have to in other languages because they have a much smaller ecosystem. So you may well have to write your own library for something it probably doesn't exist. You can just download it. So there's like I say, there's the positive of being part of .NET or JVM. The downside, I think it sort of depends on the environment. If you're in an enterprise environment, or if you're working with a big team, the hit of using JVM or the CLR is, people there already understand it. The ops team already understand it. You're not using, and if you've got C# developers or Java developers, you can train them on the new language. Java people can pick up Kotlin or Scala, and C# people can pick up F#. It's not, you don't have to learn the new tool chains. But if you're a hobbyist, if you're just working at home, and you're new and you're just looking for a new language, sometimes that is a big hit. Sometimes you just want something where you can just run it and it just works and you don't have to worry about anything else. So it's not, there's a lot of different things you need. There's different environments. Different environments need different tools. So hobbyists are different from enterprise people, which are different from games developers, which are different from So I don't think there's one size fits all.
No, absolutely. And it is interesting because, you mentioned with ReasonML that it has a tool chain and a build tool chain that allows it to compile down to JavaScript. And JavaScript has become the de facto now, because it's everywhere in the browsers. It's become the de facto assembly of the web. I'm not going to say WebAssembly because that's its whole different thing. But it is interesting, like you say, that fundamentally, obviously, these languages are all built on top. I mean, you even have things like Scala.js and, ClojureScript and all these different languages. I don't know whether F#, I'm sure there must be an F# that compiles down to JavaScript.
There absolutely is. It's called Fable, and there's a library with it called Elmish, which makes F# look very much like Elm.
Wow. See, and it's just everything, isn't it? And I'm just wondering, what is your opinion on all this kind of, do you feel that it's a good thing, or do you feel that we're kind of, do you think there's too many layers of abstraction?
I think I'm glad that there is a standard thing that we can all rely on. I mean, the bad news is it's JavaScript, but the good thing is it's
standard.
It's standard, yes. I mean, I think WebAssembly, when that comes along, will be a step forward there, because we'll have a very consistent thing that we can build on. But in terms of actually coding in JavaScript, I don't do very much front end stuff. But I mean, they're just using JavaScript and the whole JavaScript ecosystem with NPM and stuff. It just from what I read about it, it just seems like a nightmare. So using a statically typed language which generates JavaScript seems to me a much better way, or even something like TypeScript, but just something which is that where you're not dealing with JavaScript directly. That makes me happy. Yeah. It's like writing assembly,
That's exactly it.
Like,
yeah, the reason why we got C.
Yeah, exactly. And then I'm a fan of high-level languages. So like I say, the problem is you have the leaky abstraction. I think that compiling to JavaScript, then you get stuck into the JavaScript toolchain, and then you have to understand how that works. But if we could bypass that altogether, and you could literally compile to WebAssembly in your own toolchain and not use NPM and not use all this stuff, I think the development experience would be a lot better.
If you get errors or you get a stack trace from these compiled languages, or they've been transpiled down into JavaScript, they are very hard to understand because you don't know whether it's actually your code that's the problem. It could be the transpiler that's the problem. It could be a combination of both.
Yeah, exactly. And luckily, I think a lot of the transpilers do generate quite nice JavaScript. I know Fable generates JavaScript, the kind of JavaScript you would have written if you'd written JavaScript in the first place. So it's not full of weird stuff that you couldn't understand. But even so, yeah, you do need to understand. It's a leaky abstraction. You need to. It's if you're already a JavaScript programmer and you're looking for something better, I think that's a good approach. If you're not a JavaScript programmer, just using a statically typed language like Reason or Elm or something. Yeah, it's gonna get rid of 99% of your problems, but there's going to be the extra 1% which will drive you nuts.
Absolutely, yeah. I think that's a great way of thinking, going up that way from understanding JavaScript, going upwards, as opposed to. I mean, it's interesting because in all our languages now, these high-level languages that compile down into C or then they compile down into assembly, we don't typically think, right, you must learn the assembly first or you must learn the C first. But in the case of like the JavaScript world, because it's such a complex language in itself and it's got its little quirks and everything, you do kind of have to understand it, because I suppose it's reached that point where there's just so much level of abstraction.
Yeah, I mean, typically if you're using JavaScript, you're going to be using packages from NPM, and you're going to be using, I don't know, Webpack and Grunt, or I don't know. I lose track of what the latest thing is. And you might be using a framework like React or something. So you're using React from inside a statically typed language or something. And I mean, I don't know. It's complicated. You've got a foot on either side of the thing. I mean, with assembly, you don't have to do that.
That's it. So we went back and forth on Twitter about kind of what we could discuss in another show. You brought up a great talk that you did last year, which was called Designing with Capabilities, and it was interesting because we actually spoke about this a little bit when we talked about your 13 ways to draw a turtle. I thought it'd be great, maybe, we can to kind of go into it in more depth. It brought up some really interesting points, and it really did kind of highlight the idea of good code versus good design and kind of the blend of the both. And there was actually a really interesting blog post that came out on Hacker Noon last week, which kind of solidified a couple of points, especially in the code domain, which was called the non-secret formula for writing better code. And I'll bring these up, and I thought it'd be really great. Maybe we can then kind of discuss them, and maybe, if you've got any, share your thoughts on it. And then we move on into maybe some of the architecture stuff that you mentioned in the talk. What he highlighted was the fact of readability, simplicity, and consistency. And there was a couple of bits there that he mentioned, which was like the idea of the zero comment policy, which we're all very familiar with. The fact you want to focus the code, make the code readable. The fact if you use a comment, you're typically making the code too complex to understand and comprehend. And comments they could become stale very quick. It was interesting when they also brought up the to-do policy, the zero to-do policy. So typically in corporate, we will definitely see this in corporate code bases, where people will treat their code as like a Jira board or like to-do board, so they'll put that in. The self-documenting code is interesting, like with helper variables, and like the fact that the variable name is the why and the assignment of it is actually the how, and how you can use you can essentially use kind of these helper variables and variables to help guide and document your code as opposed to using comments. He then mentioned the break early philosophy, and that is a very interesting one, where having these crazy if conditions to then return and really kind of keeping your code and most important path on the first indentation. And then he mentioned immutability. We spoke about this on the show a lot, especially in the functional domain, how much easier it is to comprehend. But I think he kind of mainly, we were talking about immutable data structures and stuff. He was specifically saying, like const in JavaScript and stuff, where assignment of a variable only happens once. So I know that it's going to maintain to be, stay that way. And then the last thing was like the one line of code per thought, which is a really interesting one. So I've just kind of rattled those off, but I thought it'd be really interesting maybe to get your opinion and kind of, what you feel about what to you feels like good code. It's very hard. I think it's one of those things that it's hard to quantify. It's also like with architecture, but what actually then is for you a good piece of code?
Well, yeah. Well, the first thing is, again, it's context specific. If you're a hobbyist and you're trying to, if you're writing something which is very high performant code, then the code tends to be super optimized, very ugly, very hard to understand, but it might be good code meets the requirements of being fast code. So if I'm doing something, often when you make code fast, you have to make it very ugly and hard to understand with weird things. And that's in one situation, that's good. In another situation, that's bad. It depends on the context. So if I'm doing kind of enterprise code, optimization is normally not the most important thing. And so code which has been super optimized and hard to read, to me, that's bad code. But like I say, if you're doing, a network stack or something where you want high performance, or game programming something, then that might be that's super important to have. That good code in that case is code that's So there's the first of the. It's all relative. I remember it relates to this thing of quality. There's a classic example, because this is not just for code, it's for any kind of system, any kind of thing which is made by people, And a classic example is a plastic pen. Is that a good pen or a bad pen? A cheap plastic Bic biro or something. Is it a good pen or a bad pen? Is it high quality or not? Well, it's not as high quality as a stainless steel or gold Mont Blanc pen that costs £1,000 or whatever. But for that's maybe not what you want. For quality might be, does it write well without spilling, and is it cheap enough that if I lose it, I can get another one for a few pounds. So in that sense, a cheap plastic pen is actually a very high quality thing, because it meets the requirements for my personal requirements, which is I lose them, I throw them away, they get broken, it writes well enough. From that point of view, it's a very high quality thing. And an expensive gold plated pen that I lose, that's not that doesn't meet my requirements. So in that sense, it might be technically a fantastic pen, but from my point of view, it's not actually the best pen that I should be using. So it's all about the requirements. What are the requirements? Sometimes the requirements depend on the context. In an enterprise situation where you're working with other teams, and you have the teams may rotate over, code lasts 10 years and the teams rotate in and out. It's really important to have readable code.
Performance is not as important as understandability, because picking it up is going to be harder.
Exactly. And so, exactly. So there's the things, and using code that doesn't do anything clever, and both in clever in terms of like low level programming. So that's one of the reasons I think that C and C++ are terrible languages for enterprise code. But I also think that Haskell is a terrible language for enterprise code, because if it allows you to do clever things, you can do clever things which are too clever and no one else can understand them. And now, if you're writing for yourself, fine, have fun. But if you're writing that 100 other people are going to be looking at this code, you want to make sure the code is not too clever. And sometimes languages that let you be too clever. Lisp is another good example. You're writing code that only you can understand. And so a good code in an enterprise context is often really, really boring code. It just looks boring. Anyone can understand it. And this is, I think, one of the reasons why the design of Go that everyone complains about, that you can't do this and you can't do this, and all the code looks the same and it's all very boring looking. That's actually
it's a great design.
Strength,
yeah. It's achieved what it was actually set out to do.
Yeah, I mean, I personally I think they should have had generics, and I think they should do some other stuff. But I think in terms of their design goals was to write a boring language that would look the same to everybody, and I think they achieve that. So you just have to be. And people say, well, you can't do this and you can't do this. Well, that's deliberate. You don't want to be able to do higher kind of types, or monads or something in Go, because people don't. You have to have you're assuming that everyone in the enterprise will understand that code. Now, you could argue that you should train everyone so they do understand all that stuff. But realistically, that's just not going to happen. You have to deal the hand that you've got.
Absolutely. And we spoke about that last time, about language design and kind of, the kind of design philosophy around certain things, and why you would, why languages would choose certain ways of going. And I think it's really interesting because, like I rattled that off there with writing better code, but really that, those kind of points are really kind of directed at a corporate, kind of enterprise world where, like you said, teams will be rotating. The actual, the value and the actual cost is really of getting people up to speed with the code and understanding the domain logic, as opposed to I need to make sure the performance is ultra good. It makes sense. And, when you go down to things like C, and it's interesting, you said like, C and C++ not being great, enterprise languages. And it's because there's too much room to do magic and to do things that, as developers, we typically like these kind of trickery things because we like the, the crazy magic you can do. But code should be boring, and code should just read like a book that you already know how it's all going, because there shouldn't be any, and at the end, and it's this, weird kind of craziness. And all these kind of points which he was putting out there really are to try and aid towards that, is to keep this narrative kind of boring and kind of, expected, like Go is like the language.
Exactly. And I basically agree with almost all of the things. The breaking early is an interesting one. This thing of doing early returns. I think it's interesting how people sort of rediscover stuff from the 70s. The 1970s was a very fertile time for software development, and a lot of all the important language paradigms came out then. But they in the 1970s they invented this thing called structured programming. Which is not just not using goto statements, but it was that every function has one path through the function. So one of the problems with having early returns is that you're never quite sure where if the function doesn't do the early return, what actually happens at the end of the code. And one of the things about structured programming is that the idea is that there's only kind of one path, one entrance and one exit to any piece of code. So if you have an if statement, you always have an else statement. So it's not that, because the mental overhead of trying to understand what happens if you don't have an else. Here's an if, but we don't have an else. And then that's something you can forget about. And you overlook it. Now, there's a difference between early returns for kind of guard statements, like if it's null, return early. If it's a negative number, return early. Those kinds of things. Those are what you might call guard statements. But in your main business logic, the structured programming people would say every if has to have an else. Every single if you're doing a switch, you have to handle every single case in the switch, because you never leave anything unhandled, because if you have a lot of returns in your code, then you might get down to the bottom of the function and not return anything and have forgotten about it. So one of the interesting things is that expression-based languages don't have this problem. In an expression-based language, you always have to have an else branch. You can never have an if without an else. And so what's kind of interesting is you get that for free. With expression-based languages like F#, for example. So that's kind of cool that, there are ways if you don't do early returns, you have to come up with other ways of solving the problem. But sometimes the other ways can actually make the understanding of the code easier, not harder.
Oh, that's really, really interesting. And obviously, with expression-based languages like F#, the last statement is the return as well. So you already know that there will be a return and that something will actually get returned.
Yes, and every if does have an else. So you can never say what happens if this doesn't. In the case where in this path something happens, but what happens in the other path? You always have to consider that other path. You can never forget about it.
It's very interesting how like these semantics like this that seem like a kind of like, yeah, it's fine. We'll just have ifs without elses, because it'll make something easier. And how that ripples and how that actually can change the whole way we then do design and how many problems can happen. And it's that whole thing of, a good language design and kind of thinking in that way. But yeah, trade-offs like this are very interesting.
Well, a good example is in an expression-based language, especially without nulls, in an imperative language, you typically have a variable which hasn't been assigned to yet. And then as you go through the code, you decide, well, if it's this, I assign this, and if it's this other thing, I assign this other thing. And it's quite easy to forget to assign to it, by the time you get to the bottom. Or it's not very clear what should be the default value, which is why you have something like null. If in an expression-based language, you can't have that. Everything is an expression, so a variable is always the result of an expression. And so you never have the situation where a variable has been accidentally forgotten to be assigned to, which is a cause of bugs. I mean, I think the famous SSL bug was caused by that. So, that kind of thing. Certain problems just do not even. If you have a certain kind of language design, certain problems just don't even happen.
Moving on then, so that's talking about the code and actually, how the language is developed. And, we get a lot of aid or kind of mistakes happen due to how a language is designed. The architecture of a code base is something completely different. And really, our languages can help kind of mold that, but we have a lot more free reign of kind of how that goes. And, this concept of good design, I'm just wondering maybe what you could, what do you feel are the characteristics then of good design?
Yeah, I think good design is where it makes it hard to do the wrong thing. So again, this is not just for software. This is for the real world. There's a very popular book called The Design of Everyday Things by Don Norman. And the whole book is all about the real world problems when things are badly designed. And the classic example is a door that, you can't tell whether you're supposed to push it or pull it. You see people in buildings pushing the door and it won't open, and they realize they have to pull it, and they feel stupid. And because the design did not make it clear whether they should be pushing or pulling. And he talks in the book, he's like, a good design will make it what he calls an affordance, a certain way it makes it really easy to do something. So if you want a door to be pushed, you put a flat plate on it. And if you want a door to be pulled, you put a big, handle on it. So you pull the handle and you push the plate. And if you do that, people tend not to make mistakes. And it's the same. I mean, anything like that. If you don't want people to do something, don't let people do something and then tell them off for doing it.
Don't give them the option to actually make the mistake.
I mean, it's a classic thing is you have like a glass table and then you have a note saying, please do not sit on the table. Well, don't, if you're going to have a table, people are going to be do not put anything on this table. Well, it's a table. You're supposed to put things on it. So if you don't want to put things on the table, don't have a table there, or make the table out of something stronger. Or his example is make the thing slopey, make it at a slant. So you can't put anything on it because it will just slide off. So there are things, there are techniques you can do to rather than putting a note on something. If you ever see a handwritten note, something, please do not turn this switch off. Please do not pull this door. Please do not put the thing on the table. That's a clue that you've got a bad design.
And that's kind of like a comment in a bit of code. It's having to read the code. It's having to experiment with the code. You can kind of think of it in the same way.
That's right. So you have a classic example of an API, and you call the API, and it says, sorry, you can't do that. Well, if you can't do it, why did you let me call the API in the first place? And, that most APIs, you have these affordances, ways of doing something, and there's no clue about what you can and can't do in any given context. You basically have the equivalent of these handwritten notes, which we call
passive-aggressive handwritten notes saying, you
yes,
done this.
Don't do this. And it's like, well, if don't give me an API and then tell me that I can't do it. It requires, it just requires a lot of extra effort on the developer. So to me, that's a bad API. So this is what leads to in object-oriented programming, you might have the Fluent API, where you call an object a builder object, and it gives you two methods, and then you call one of those two methods, and that gives you another thing, and there's only 5 methods on that one. So at all points, you're kind of guided as to what you can do. And you can never do anything stupid because the API literally won't let you do that. And so that's an example of a good design. And in the designing with capabilities talk, I talk about that in a more general way of any API, which is rather than having this sort of passive API, you have an API that returns you functions. So you call something and it gives you back a list of functions or function pointers or endpoints, RESTful endpoints, whatever you want to call them. But you get these things back, and at any point you only have a limited set of things you can do. You have to pick one of those things, and so the API guides you in terms of what's doable and what's not doable.
Yeah, because it's really interesting in your talk. You focus more on the design in the context of security and kind of looking into how security design and Polar and things like that. What inspired you to look into that and then look into exploring it maybe in these designs?
Yeah, so in the security world, they have this thing, the principle of least authority or the principle of least privilege, which is don't let people do what they shouldn't be able to do. It's really obvious. Don't give if people can't go into the room, don't give them a key to the door.
Yeah, don't just put a comment saying don't use this.
Exactly. Don't give them the key and then say don't use this door. That's because people either accidentally or sometimes maliciously, but sometimes just accidentally or stupidly, they'll do the wrong thing. And so and it's the same thing with on your desktop. If I want to delete the operating system, I have to, in Windows, you get the elevated things like, you need to be an admin to do this. And in Unix, you have to use sudo or whatever. You don't want to be running as root, even if it's your personal machine, because you might accidentally do something stupid. You want to be, even if you can elevate your privileges temporarily, but you just basically don't want to run normally as a kind of privilege. You want to have an absolute minimum number of things you can do in general, just enough to get your job done. So that's the security principle, and exactly the same principle. What my take on this is that good security, it leads to good design, because in good security, it's like you can't do this. Like a good example I use in my talk is an example of a configuration file. So you could say a very simple example is like, well, here's the file name of the configuration file. Write anything you like there. Well, that's obviously bad security because you could write terrible stuff in there. But it's bad design because it's very hard for the user to know what they should be writing. You're not giving any clue, at all. If you have an interface which says, here's an interface where you give me a key value pair, and then I will take care of putting it into the configuration file. And, that way you don't need to have permission to write to the configuration file, and you don't even need to know how it's structured. It could be a any file, or it could be a YAML file or a JSON file, whatever. It's like, you don't need to know. So it's better security. I don't have privilege to do anything in the file system, but it's also better design because the things I can do as a user is constrained to be much more related to what I actually need to do, which is put a key value pair in. I don't care how the configuration works. I don't need to know that. So by good design, and this again goes all the way back to the 70s, which is that good design is often about data hiding. It's not about what you can do. It's about what you can't do. And it's a classic thing. If you expose a piece of data or an operation, people will use it,
It's fair game.
And exactly, it's fair game. And again, accidentally or not. And if you the whole thing of data information hiding, which was, invented in the 1970s, if you hide information, people can't mess it up because they literally don't even know that that's there. Therefore, they can't depend on it. And if they can't depend on it, it makes you now have more decoupling. The whole thing of being tightly coupled between one system and another system is a bad thing because the systems, ideally, subsystems should be able to change independently. They can't change independently if they are tightly coupled. So anything that causes coupling is bad. And exposing information that is absolutely not needed is an implicit kind of coupling. Exactly the same principles that govern good security govern good design, is what I'm saying. So if you don't have that information, you can't depend on it. And if you don't depend on it, you can't have a coupling. So a good design, the less you know about a subsystem, to me, that's a better design. You should only know that
you're going to get into trouble.
Exactly. The less you know, the less you can depend on. You should only depend on. It's the classic thing of depending on an interface. It goes back to object-oriented design principles, which is you depend on the interface, you don't depend on the implementation. And so the interface is exactly the minimum thing that you need to do, the minimum amount that you need to know to get your job done. And anything else is irrelevant, and it should be hidden from you.
Some of the design principles being highly popularized, like the solid principles, and that includes things like single responsibility and the idea of like interface segregation. I find it very interesting because actually one thing in your talk, which you kind of expanded on with the tic-tac-toe example, it was providing this kind of polar, principle of least access philosophy with the fact of using a dependency injector. And I thought it was very interesting how you used a dependency injection as a form of like global authorizer, and how you kind of move from, providing a whole interface, which, in a security, if you look at it from a security point of view, they can do so much with it. This interface may be just accessing the database raw. It could be inserting, updating, retrieving, to then actually just providing a function, which is just, this is exactly what you can do. Even, with the fact of partially applying that function really with saying, okay, this is what you can do and you can only access this user. Looking at dependency injection as this global authorizer, I thought that was a really interesting way of thinking. Could you explain more about that?
Yeah. So the security people talk about authority, which means, do you have permission to do something? Do I have the authority to modify this file in the file system? Do I have the authority to update this row in the database way? So the principle of least authority is you don't have the authority to do stuff that you don't need to do. When you apply that to the design from a software design point of view, it's the same thing. You don't have the authority to do stuff that you don't need to do because you don't want to create a coupling. You don't want to create a dependency on things that you don't need to know about. So in kind of statically typed object-oriented programming, you often have these interfaces. A classic example would be some sort of data access object interface or a repository interface, whatever you want to call it. And, in this interface, there might be, everything to do with a customer. You might have a customer database, customer data access interface, and it's got, update the customer, delete the customer, insert a new customer, change the customer's password, send an email to the customer, whatever it is, a whole bunch of stuff. Now, in any given workflow, if I'm just, adding a new customer from the web front, I don't need to know how to change the customer's password. I don't need to know how to delete a customer. And yet we tend to have these very big interfaces, often with 20, 30, sometimes hundreds of methods on it. And we pass the same interface into all the different workflows or all the different controllers or however you want to organize your code, which means that from a security point of view, a badly behaved, piece of code could delete the customer. But from a coupling point of view, you're never quite sure which piece of code is using which function. And so this is a thing of what having too much authority. The interface exposes way too many things, and you basically, in any given workflow, you basically only need to do one or two things. You need to update the customer or, do something. You very rarely need to do all these things. And we have a tendency to put everything together by entity, by the type of thing, all the things you can do with a customer, which is all the things you can do with a product, something, which I think is a very bad design because that's not how the workflows work. Creating a customer might be easy, but deleting a customer should be really hard, because that might be only an administrator can do that, or only a special kind of workflow can do that. Similarly, changing a password, it's not the kind of thing, or that an everyday workflow might want to do. You might want to have some special authority on that before you do that. So, putting everything in these giant interfaces is almost always a sign of bad design. And the thing in the solid principles, they have the interface segregation principle, which is leaning that way. Don't depend on things you don't care about. The only one reason to change, which is the single responsibility principle, and so on. They're kind of the problem with the solid principles. They're very kind of fuzzy. It's not very clear how to actually apply them. You can debate. Is this
still relative?
It is, yes. Should this interface be segregated or not? And so, but the security principle, the reasons I like the security principle is they are crystal clear. It's like, if you don't need this, you don't get it. There's no ambiguity. So if I'm passing in an interface to a controller and it's like, here's the stuff you can do in the database. If you're not using that function is not on that interface. That is, you absolutely have the absolute minimal things. Only the actual things you need to know is what I give you. And so that to me is a very crystal clear design goal, is a design principle. And it's also much more based on a practical thing. The whole, it's rather than these kind of fuzzy things, it's, the principle of least authority is a very explicit principle that doesn't have any ambiguity in it. And one of the reasons we don't do that in an object-oriented language is because that means we have to create a separate interface for every single activity. Yes, that's really annoying. That's good design, but it's really painful to do. One of the nice things in functional programming is we don't really create interfaces. We just pass in functions. So here's a function that updates a customer. We don't pass you in an interface with 20 different functions on it. We just pass you in that one function. So we don't really do dependency injection in such a heavy way. We just, we pass in the minimal set of functions you need to do your job in this particular context.
Absolutely. And it's like you pass in that and it's what can you do with it? Well, I can just invoke that function. That's it. There's none of this, oh yeah, this interface has this, and this. And it's that kind of ambiguity. It's just there's this one thing it can do. And it's always interesting, the interface segregation principle, because if you look at it at its extreme, it is just single method interfaces, which then are just functions. It'd be great to get your opinion on this, using the solid design principles and in the context of functional programming, and also how you feel in a typical flow, like kind of a functional programming code base, architected code base is different to an OO code base, and which ones are better in respect to good architecture.
Better. I don't think whenever in a sense it's better than what, So I'm not gonna say which is one's better, but what I will say is there is when you do functional type architectures, they tend to follow a sort of pipeline model, because functions have inputs and outputs. The fundamental principles: functions have inputs and outputs, and then the way you build systems is you compose smaller functions together to make bigger functions. So the overall system also has an input and output. So if I'm doing like a website, rather than having a controller, a customer controller and an order controller and a something controller, you'd have a whole bunch of functions, each of which does one thing. And each of these functions is designed as a pipeline. So for this particular input, for this particular path in the URL, I call this one function. And the input is everything from the request, the HTTP request, and the output is the HTTP response. So you have this pipeline model, and each pipeline is specifically designed for one particular workflow, for one particular scenario or use case. With an object-oriented design, you tend to think of objects and the behavior that goes with the object. So you tend to have these big objects, like a controller object is everything to do with controlling, all the behaviors to do with a customer go here. And then in your domain, you have a customer, an entity customer, an aggregate, whatever, and everything to do with customers goes there. And in the database, you might have a customer repository interface, and everything to do with updating the database goes there. And it's, like I say, it's very easy to end up having way too much stuff in any given object, because you just tend to stick everything there, and you tend to forget about that each workflow. I think one of the things is that in practice we think there's a lot of commonality between different workflows. There's almost always some subtle difference between for example, the workflow to update a customer and to delete a customer, or to update a customer and to insert a customer. There's actually a lot of subtle differences between them. The data structures are not quite the same. The authentication is not quite the same. The logging is not quite the same. The side effects are not. It turns out these are not exactly as similar as you might think they are, and we tend to kind of put them all into one pile. But if you think of them always as completely separate little pipelines, and you design each pipeline from scratch, to me that means you have the least authority, the least amount of stuff you need to know makes for a better design. And I think the tendency for functional programming is to do that more, because in a functional program, because you tend not to use interfaces. I mean, although you can do equivalents of interfaces, you tend to pass in a function for each thing. Anything that this particular workflow needs to do, like update the database, that would be a function parameter that's passed in. And if you need to send an email, that's another function you pass in. And if you do something else, that's another function you pass in. And as a result, if you need to do 20 different things in one piece of code, you have to pass in 20 different parameters, and so that immediately starts getting really ugly, and you start saying, well, maybe I need to refactor this. I mean, there's a great quote. It says, if you're passing in 20 parameters, you've probably missed a few, because You should only have one or two. Ideally, you keep your workflows very small. Now if you have an interface, it's quite easy to have 20 methods on an interface. And if you need another, even if some other new tasks comes up, you just I'll just add another method to the interface.
It's the path of least resistance, isn't it? It's just that I can add another one, and it's the smallest diff in the committed log, and it's just, I think that's the interesting thing though with the single responsibility principle and looking at them from a functional point of view, where a function is it's a horrible smell when you've got lots of parameters, and you can really clearly see it, visibly see that I've got all these parameters, and the fact that typically a function will do one role, one job, and do it well. Whereas in an interface, that's when it gets hazy, because an interface is like, well, yeah, when I'm updating a user, I need to be able to update them, and I also need to be able to do this other thing as well. And it's a lot more clear cut with a function that it should do one thing and that's it. Whereas an interface, because you start batch these things up, that's where the kind of haziness comes with it, because it's all relative to the context you're in. Whereas a function, it's kind of, no, that's it. It does that one thing.
Exactly. I mean, if you can only have, let's say your programming language only allowed you to have, 2 methods on every interface, your code would look very different. Sometimes it's good to have the language actually creates constraints for you. And so, if you do functional programming, it is like every interface can only have one method. And so your code automatically is designed in a different way. So, yeah, I mean, sometimes the OO model is good. I'm not saying that one's always better than the other, but I think in general for understandability, the other thing about the functional model is that everything is always very explicit. You always pass in, a function, anything the function needs is passed in as a parameter. And there's no kind of effect there's no globals, there's no side effects, whatever. Generally, it's pretty easy to understand what a function does just by looking at what the inputs are. Now, with a method, one of the problems with object-oriented programming is a method may have dependencies which are elsewhere in the object. So if I look at a method, it may depend on things which have been passed in through dependency injection in the constructor, or it may depend on other fields which have been set by other properties or something. It's not, by just looking at a method on an object, you can't tell exactly what it needs to get its job done, which is why refactoring, pulling a method out of an object can often be very painful, because there's a lot of kind of implicit dependencies that method has. If you have it's a difference between an instant method and a static method. If it's a static method in a sense, then everything does have to be passed in. So one of the reasons why, some people are moving away from objects and towards static methods, which is sort of like functions, is that you do have to be much more explicit at all times about what this thing needs. And it's, again, with the large objects, the implicit state. I mean, sometimes it can be good to hide stuff, and sometimes it's bad. In general, I'd err on the side of being more explicit. Sometimes it's nice to have an object where all the state's inside and you don't have to worry about it. But in general, it's better to err on the side of being too explicit than too implicit, I think.
That's interesting, because that is the different, the difference between OO and FP is that FP, you're very explicit on what you pass in and what you return back, and OO, the data hiding, information hiding is its kind of strength. But actually, it seems like a lot of this is coming from my point of view, where a lot of our kind of best practices are to actually push towards more of a functional approach and more of an explicit approach, and take away some of the implicitness that kind of comes around from data hiding.
Yeah, I think implicit in general is a bad thing. I mean, I think the behavioral thing of it certainly has its place, but I think for most programs, the more explicit you are, the more the dependencies are explicitly passed in rather than being implicitly available. That makes for code that's easy to understand. It also makes for code that's easy to refactor, because one of the things in a functional system is a function can live anywhere because it has no dependencies. You can have a module that has functions that do this, and another module that has functions that do this, and you don't tend to group them by, here are all the customer functions.
Well, a function is just its parameter; it's just type definition of what it can do, and you can replace it with another one that matches that.
Yeah, exactly. But I mean, you can organize. You can. If I want to refactor a function, literally it's just copying and pasting it from one file into another. I tend not to have to worry too much about picking up the jungle that goes with it. There's the classic quote, you want the banana, but you get the gorilla and the rest of the jungle. And it's like with functional programming, you just get the banana because the banana is the parameter. The jungle is not being passed in as a parameter.
With the OO world, there is a beauty to some information hiding, and that stops the coupling. And I find it hard sometimes to kind of reason about, which way, because I think some people, go too far down the information hiding route and too much abstraction and too much of, being kind of implicit and being able to do this. Whereas, the explicitness of a function and kind of just simple case of these functions really can be far more readable. And as you say, reflectable.
Yeah, and it's a tough one. I mean, information hiding is good. My philosophy is you do information hiding at API boundaries. So within the context of some piece of code, all the functions have very explicit parameters, and everything's very explicit. But the API that you expose to the outside world doesn't have that. So that's the difference between sort of an API versus the internal stuff. So the API shouldn't, for example, if I want to save something to the database and I have an API for that, then the internal fact that I need a file handle and a database connection or whatever, so that's not exposed to me. I don't care how it works. I just want to do this thing. So the difference between API design and an internal design is I think it's important.
And APIs are all relative as well and context specific, because typically someone will think of an API as something that's publicly available to, maybe you're publishing it or you're using it on a web API or something. But APIs are just, in general cases, to your code as well, within a bounded context.
Absolutely. Subsystems. I mean, the whole thing of microservices versus monoliths, as if monoliths can't have subsystems with explicit APIs between them, just like microservices. I mean, absolutely. I mean, again, going back to the 70s, you design your subsystems so that each subsystem has a very explicit API, and anyone who uses it, that's the only thing they can use. They can't use any of the private stuff. They have to use the public API for doing stuff, and you can do data hiding, and that way you avoid coupling between the various subsystems in your program. There's no reason why you don't want to have the big ball of mud. You want to have well-defined subsystems, each which does one thing well, and they talk to each other through little APIs. So designing APIs is something you should be doing all the time. I don't think APIs is not just like a big heavy-duty thing. It's like every single subsystem should have an API that you use to do stuff with. I don't think you should be able to reach in.
And that's the boundary for the context or information hiding. And it makes complete sense.
Exactly.
You kind of have touched upon it, but I didn't really kind of explicitly say, like the concept that you brought up in the talk is this concept of a capability. And it'd be good maybe if you could just like describe actually what a capability is. Yeah,
so a capability is just a fancy word for a function that you can call to do something. If the capability comes from security, well, do you have the capability to write to the file? Do you have the capability to, read the password or whatever? So,
but it's a nice way of thinking of it, because it really does, it does the whole principle of least access thing. It's the capability. If you word it that way, it's a lot nicer. Like, do I have the capability to edit this person? Not, do I have the capability to edit a person or access to invoke a function that edits a person?
That's right. And so, I mean, and a good example between the subtle, you end up doing a design differently. So in a traditional model, you might pass in a customer repository interface, which gives you the ability to update any person. You pass in the customer ID and the rest of the stuff, and it updates the person. Well, if I'm on the website, I should really be able to update only my information and not anybody else's information. And that's a security breach waiting to happen right there. So in a capability thing, you start off, you log in, and you get back a bunch of functions. And one of the functions is you can edit this customer, but you can't pass in the customer ID. The capability that you get back is a function that says, update your email or whatever, update your name. But the customer ID that's being used is baked into that function. You don't pass in the customer ID as a separate parameter. So that capability only lets you update that one particular customer. And so from a security point of view, it's good because you can't update anybody else's data. But from an API point of view, that's also good because you can't accidentally do something stupid. You're guided as to what you can do. You can update the customer. You don't need the customer ID. That's already sort of baked into the capability. And a lot of stuff can be baked into capabilities. Authentication. Your information about who you are. That can be baked into the capability because they are functions. I mean, capabilities and functions are very similar. One of the cool things is the capabilities that can be passed around. One of the problems with role-based security, the classic model, is that you can do stuff, but I can't do stuff. And often it's a common situation where I want to let you do stuff on my behalf. And classic security systems tend to go overboard on restricting people from doing stuff. And what's also really important in a good design is allowing people to not just to restrict people, but to allow people to delegate. And a real world example is if I am your manager and you're a new employee and you've only been working at the company 6 months, so you don't have any you haven't got your swipe card yet or whatever, because it always takes 6 months to go through the IT security process, whatever. If I want you to go to the closet to the cupboard or whatever and get some paper, if I have a key, the old-fashioned thing, I have a massive set of keys, and there's a key for each room in the building. I can give you the key to the supply room, but I'm not giving you the key to the server room. I just give you the key to the supply room, and then you go and get the paper, or whatever, and then you bring me back the paper and give me the key back. So I'm delegating the authority to do that. Now, if you have a swipe card system where nobody has a key, I can't delegate authority. All I can do is give you my swipe card, and then you can get to any room, anything that I can get into, you can get into. So that's actually a much more dangerous thing. This sharing credentials or sharing, that kind of stuff is really bad. So the capability-based thing, where I give you a particular capability to do one thing, is actually a really nice approach for a lot of problems. And we actually see it a lot now on the internet. So with a Google, let's say we have a Google Docs, and I've written this Google Docs and I want to share it with you. I don't have to set up a whole password thing and give you permission to do it. I literally just send you a link. And the link has some very complex, hash code in it or some whatever it is. With that link, you can edit the document. So I have given you the authority to edit that document just by giving you the link. So that link is basically the capability that gives you permission to edit the document. It's true that if that authority then gets shared with somebody else, they can, someone malicious can edit the document. But the downside, you've got the pros and the cons. The pros is that it makes sharing much, much easier. And there's a lot of other things which work the same way. Where you actually share a link. Every time you share a link to do something, you share a link to Dropbox, you share a link to something. That is basically a capability-based model in action.
Because one of the really interesting things you did go through in the talk was the tic-tac-toe example. And I don't know, have you got those, because you've got the slides and everything, have you got the code examples available on GitHub or anything? Because that is a very interesting example to clearly kind of show how these capabilities can be built up.
Yes, I'm not sure, but just to explain what that was. The tic-tac-toe example is the difference is a good one to show the difference between kind of capability based and non-capability based. So if a non-capability based, you can just move in any of the 9 squares, and then the API says, "I'm sorry, you can't do that," because you get an exception because it says, "Well, that square's already been taken."
It's the whole paper note thing again, isn't it?
Yeah. So in a capability based one, you make one move, and then you get back 8 different capabilities, which is there's the 8 moves the next person can make, and then they use up one of those capabilities, and you get back 7 capabilities, which is the moves you can make, and so on. And then when you get to the end of the game, there are no capabilities left, so you literally can't keep playing when the game's over because you have no capabilities to make a move. So the way the design works is subtly different between a kind of regular API versus a capability-based API.
You can't go, I don't know what the negatives are of providing such an API, because I think it clearly expresses the intent far better and, providing just say this ad hoc move method with a couple of parameters. And again, you don't know unless it screams at you that you've done the wrong move, or if it even does that. Because in the first examples you showed, you're able to violate that by just carrying on the game or replacing, a naught with a cross, etc. So in the real world, how have you found to use this? Have you had a chance to use this kind of approach?
To be honest, I haven't actually used it myself that much because it is extra work. I've never had to write. I haven't written a commercial thing where I need to worry about doing this. So it's really, I think it depends on the context. Personally, I think it's interesting to understand as a sort of a design principle. I think in many situations, anyone who's writing a kind of a RESTful API or anything where they need to do, serious security, I think it's definitely worth thinking about. The tic-tac-toe example, if I make the wrong move, it's not the end of the world,
Picking the right API boundary to actually use it on. And typically, you're saying the HATOS world and the RESTful world, RESTful done right, you will use this kind of capability approach. And it will allow, the API, which is a third party, to guide through the system, through the states in a valid manner without this kind of, I know that URL, I'm just going to hard code the URL and I can kind of interpret kind of what actions I can do based on, the URL names, as opposed to this is the actual general flow of how you should be using it.
Yeah, and it means the client doesn't have to understand what's allowed. With tic-tac-toe, even that example is like, I have to understand, if I can play any of the 9 moves, the client has to say, well, the client has to understand the rules of the game. They have to say, well, I can't, even though I could play on this square, that square is already occupied, and really I shouldn't let the user do that. With a capability-based approach, the client doesn't even have to understand how the game is played. You literally, here are the 8 things you can do. Here are the 7 things you can do. So it's a lot less business knowledge has to be on the client side, and it can stay on the server side.
Yeah, because even looking at it from an implementation kind of manner, a UI that if you had this one method move, and you would then have to store the state of every other method, how it's been presented. Okay, that person's made that move, and you're leaking out to the client that logic that obviously the move then is valid then and kind of keeping them in sync with the server. Whereas if you had this capability approach, you could just refresh that UI every time because based on what the API is giving you exactly what needs to be presented and how. And there is nothing on the client side that needs to be maintained whilst using that because it's all being provided to you.
Exactly. And again, you have the decoupling is much stronger because you only have the client can't know anything other than what you give them. So it makes if you're doing an API that you need to add to in the future, it makes it much easier to add to the API because you guarantee the client is not doing anything that you're not letting them do. So if you're doing versioning of APIs, it is a great approach as well because you could always be sure that the client has never done anything stupid.
Definitely. And like you say, it's a great thought experiment. And sometimes it's great to kind of push this to the extremes, like in the examples you've done, so you can clearly see how it could be used.
I think it's a toolkit. I think, if you're a programmer, you should have a set of tools available to you. And part of the thing is knowing that, not everything is a hammer. And everything needs a hammer. So sometimes you need a screwdriver, sometimes you need a hammer, sometimes you need a chainsaw, whatever. The more tools that you have available to you, the wider your toolkit, I think that makes for a better developer. So this is another thing to add to your toolkit.
Definitely. And on that note, Scott, I think it's a great place to stop. I want to say thank you again so much for coming on. It's always great to chat to you. So audience, it's been another great episode and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.